Good afternoon, everybody. I'll try to put 2 years of very hard work into exactly 15 minutes as from now. I can't guarantee I'll make it, but I'll try. I'll do my darndest. So, there it goes. Okay. This study is concerned with difficulties in the identification of English nuclear pitch patterns in intonation dictations taken by a group of students at the Joaquín González Teacher Training College, where I specialized in phonetics. The starting point for this study was a series of observations in learner performance in dictations at the Joaquín González. I noticed that, of course, there was a failure to perceive some tones. That is, the teacher dictated, for instance, a fall and the students marked a rise. Failure to identify tones. And some pilot tests, informal tests that I conducted with some of these students and other students from other courses, in which they had problems discriminating in minimal pairs. For instance, words bearing a fall and a fall rise, they heard them exactly the same, as the same tone. And also in learner oral production, for instance, in listen and repeat activities, in which I would say hello and the learner would say hello. So it was very clear that the learner had not perceived the fall rise and had heard a fall. So I started to wonder what was going on. Right. Skip, to be concise. This study has taken into account some models of speech perception. We start with L1 speech, and it takes into account a model by a neurolinguist called Patricia Cole, who has done extensive research work in the acquisition of L1 intonation and vowels. She proposes the native language magnet theory. And those drawings that you see there are a metaphor for an effect that takes place during the first 6 months of life. At the age of 6, babies can already discriminate between two similar sounds in their own language. It seems that during those 6 months, the brain undergoes a very hard task of acquiring this skill to distinguish between acoustically similar sounds and taking into account what are known as exemplars. A good exemplar is a sound to which the listener has had repeated access and has been established as a kind of model, a prototype. Now this prototype, if you look at picture A, it's the dot in the middle. This prototype, says Patricia Cole, acts as a magnet. All the other incoming sounds, which are acoustically very similar, are attracted by this magnet in such a way that the listener perceives all those sounds exactly in the same way. If you could measure, for instance, all the vowels of all the speakers in this room instrumentally, you would find that the frequency of these sounds are not quite the same. And still, if I say ah, she says ah, everybody recognizes that's vowel number 4. What is it that makes it possible for listeners to identify the same sound when the production of so many different individuals are different? So this is the explanation that Cole proposes. For L1, what happens in L2? This is just an illustration. You're not meant to read the little print, don't worry, I'm not that merciless. But just to show that the same process can be applied to English on the left and Spanish on the right, where the natural boundaries, perceptual boundaries with which we're born, undergo a reorganization of the boundaries So that by the age of 6 months, an English baby exposed to English will have the perceptual space on the left with 12 boxes, and a Spanish or Argentine baby will have partitioned the same natural space, because we're all human beings, so we all have the same organs, auditory organs, but will have partitioned the same space into only 5 boxes. So of course, what falls into the central box in English, for instance, one of the 2 central vowels, number 11, number 12, the schwa there, will probably fall in the first box, which means then that what an English baby might perceive as, for instance, as an air sound, as a Spanish listener listening to English air might identify as in. And this is why some students, for instance, you tell them, say bit, and they hear bet. Similar sounds. So the problem is with similar sounds. So this is when we come to Flegge, who deals with the speech learning model. And this is for L2 acquisition. In the SLM, there is a process called perception equivalence. There is a difficulty in distinguishing L2 sounds from L1 sounds if these are similar. So the traditional, I don't understand it or I don't hear it because it's different and it doesn't exist in my language, that doesn't work here. Here the story is, I don't understand it because it's too similar to my language. Those L2 sounds with only slight differences from the L1 sounds are the most difficult to discriminate and to produce. The L2 sounds which are furthest from the L1, which have no equivalent in L1, are the easiest to learn, because they cannot be associated with any native language category. A new category will be formed for those sounds. So if the sound is very different from the ones we've got in Spanish, Flegge says, that should not be a major problem. The problem is, I repeat, the similar sounds.